All right, now in this section, we're going to talk about the ultrasonic sensor, and we're going to show you how to get this tested so that you can incorporate these same code elements into your project. Now, I just want to start off by showing you the materials that I've got right now. So I've got my microbit and my microbit shield, and you'll notice I'm powering it in two spots. I'm powering it here, and even though this is only giving it 3 volts of power, the reason why I'm using this is that now I can connect to serial and see what this guy is detecting. The other thing I've got here is the one on the bottom. This is going to give me 5 volts of power. I've got my ultrasonic sensor, and you'll notice that on your ultrasonic sensor, this guy actually has 4 pins, okay? So now I need DuPont cables from female to female that have 4 cables in there. So that's what you'll use on this particular project. So let's get started here. As always, we're going to start with the wiki. Now, the ultrasonic sensor is really unique how it works. Let's move this off to the side and let's zoom in. You'll notice that at the bottom of this ultrasonic sensor, there are 2 letters, T and R, transmitter and receiver. One of these is going to send out really, really high frequency audio. So we won't be able to hear it, dogs won't be able to hear it, really, really high frequency audio. That audio is going to travel away from the ultrasonic sensor. It's going to bounce off an object. So for example, here's my phone here. It's going to bounce off an object, bounce back to the ultrasonic sensor where it's going to be received and detected. And it can use the time that it went from when it got sent to hit and bounce back to calculate the distance that it is away. It's really, really cool. Now, I'm not going to go into the technical part of how this thing works. There is some documentation online here. But they use it in all sorts of things. You can get measurements from it. You can use it for obstacle avoidance. And that all of that is great. This is the information on kind of how it works. And notice that it'll work between 2 centimeters and 450 centimeters. And then it's got sort of the basic principle of how that works in there. Notice it does not require a ton of energy. It requires 0.5 volt. So even if we didn't have us hooked up to the bottom of our microbit here, and we were just sending it through the top, this would probably be okay just off the microbit. So you'll notice that when we connect it up, there are 4 pins. So there's a VCC, and notice that goes to the V1 pin. That's our voltage, okay? We have 2 pins in here called trigger and echo, and then a ground as well. So we're gonna go, as always, ground to ground. And then these trigger and echo, we're going to put echo on number 1 and trigger on number 2. Now, what's important to know is that when you look at these guys, they're not always going to be exactly the same as the diagram. Now, it just so happens in this case it is. There's our voltage, there's our trigger, there's our echo. So we're going to follow this diagram. We're going to put trigger onto pin number 2. So here's our diagram here. Trigger is going to go onto pin 2 of our microbit shield. Echo is going to go onto pin 1, and we're going to leave pin 0 free. So let's go ahead and wire this up just like the diagram. Overhead so you guys can see. Okay, I'm going to choose my colors again. I'm going to choose black as my ground. I'm going to choose red as my voltage because that just makes sense to me. And then I'm going to use brown as my echo. Brown as my echo, and white here. Sometimes it's easier to go in order so you don't have to try and fit things in the middle, but that's okay. White is going to be my trigger, okay? I could have put brown to ground, but this will work just fine. So now let's go ahead and wire it up to here. So first things first, I'm going to look back at my diagram here. I got trigger to pin 2. So in my case, trigger is white. And so I'm going to go my white cable onto the pin 2 signal. Pin 2, there we go. Sorry, my head got in the way. Pin 2, that's my signal cable. I'm going to move my black to my ground. Doesn't really matter where that one goes. Red to red, it can go on any of those red ones there. And then finally, I'm going to put on pin 1, that is my brown cable. So you can see I am wired up. So let's zoom in a little bit. Let's make sure we get focus here. Beautiful. So I've got my trigger pin on pin 1, my echo pin on pin 2, and then I've got my ground and my voltage connected up there. So this guy's wired up. Now, when we go to set up and test this code, what you'll notice is in the documentation there's two versions. There's code 1 and there is code 2. We're going to look at the code 2 because this is going to teach us how to install a library. So in order to do that, I'm going to go to my make code site. I am going to create a new project and call it Ultrasonic Test. Now, in order to, when we come back to the wiki here, in order to add what we call a package or a library, we need to come down here to this Add Package button. Now, let me tell you why we do this. There's a whole bunch of complex math that goes into making this ultrasonic sensor work, as it calculates the distance that audio has traveled between there and back. We can code that math, but often it's easier to just take someone else's code. So most of these things that are really complicated will come with what's called a library. So to install the library, we click the Advanced tab here. We scroll down to the bottom to where it says Extensions. Now when we go into extensions, we're going to type in the word sonar. And when we go to sonar, we're going to see this little guy come up from microbit. We're going to click on that. And what you're going to see is that it is going to install a sonar section. And so you can see right here, it has installed a new tab called sonar. And inside of it is just one box. Okay? This is the box that we're going to use to get this thing set up. So let's go back to our code here and let's see what they do. We've installed that sonar and we're ready to go. So they've got some on start to say the lights turn on, and then they've got a variable, and we're going to set that variable to this thing here. We're going to tell it exactly where our trigger and echo pins are in centimeters, and then we're going to show that value, pause for a quarter of a second, maybe less than a quarter of a second, 50 milliseconds, and then we are going to serial write that value. So you can come back and reference this as many times as you want, but we're going to do the same thing. I'm going to basic, I'm going to show an icon, and for me, I am going to do, let's do a ghost this time, okay? And what I'm going to do is I'm going to create a new variable, and I'm going to call this distance. They called it item. I don't like calling it item. Let's call it what it is. This is distance, okay? And we are going to set distance to, let's go back and make sure we're doing this right. We're going to set distance to whatever this item is. Whoops. So I'm going to come into my sonar, grab this circular thing, and drop it in there. Now you'll notice that ping, or the trigger, is set to pin 0. Echo is also set to pin 0, and the units that we're using is in microseconds. So I'm going to change this to centimeters, and then what I'm going to do is I'm going to go back to my, I'm going to go back to my device here, and I notice I've set the trigger pin, which is white, to pin 2. So I'm going to come back, I'm going to set this to pin 2. The echo pin is set currently on my device here. The echo pin is set currently to pin 1. And so I'm going to go in and set to pin 1. Now you can change this. This is just how I'm doing it. So the echo pin is now pin 1. So now I have set that distance there. So now let's go back to our thing. It wants to show a number, so let's show a number on the screen, even though I think this will be kind of useless, but what we'll do is we'll go basic, show number, whatever that distance variable is, and now let's come down, we're going to go serial, and then I love this serial write value here with that X. I'm going to say distance is equal to whatever the distance has been set from this. Now it's got it pausing, and I think that's probably smart. It has a little bit of a pause in here. So let's put a pause in there for 50 milliseconds, just like they did. So we'll go basic, pause here, and we'll go for, sure, let's go 100 milliseconds instead of taking that even smaller. So now let's test this sucker out. So what I'm going to do is my microbit's been linked. I'm going to download that code to my microbit, and you can see here, my microbit turned on, and now it's showing me this number that's scrolling across the screen. So I got 148. Now remember that number is going to be centimeters. Now this isn't super helpful, but let's just go, I'm going to hold my hand up really close. And now it's going to say 4 centimeters. So it's detected that my hand is about 4 centimeters away. I'm going to hold it back a little bit, roughly double. And it's given me 12 centimeters. Now there's a more accurate way to read this out. So let's jump into my console here. I'm going to show console for my device. And I'm now receiving this value. It says distance 145. I put my hand in front of it. And then now it says distance 5, 4, 5. I'm going to increase the distance of my hand. That takes it to 8. That's 7 centimeters. It's now gone a little bit farther there. I'm up to 13. And so this guy is working. This is kind of exactly how we want it to work. We can make this thing even more efficient. Let's go back here and let's rewrite some of that code. Let's get rid of this show number. Let's get rid of that pause. And let's just serial write that distance. So I'm going to get rid of these. Oops, you can't see that. I'm going to get, oh yeah, you can. We're going to get rid of those things there. I'm going to download that code again. And so now when I pull up my device, it's going to stream that data way faster than before. So you can see it's coming in real fast here. I'm going to push my hand away. You can see it's up to 30 centimeters. Okay, and I can bring it back in and we go all the way down to about 2 centimeters. So this guy is working and ready to go. So the question is, and the question that you'll have to ask is, how far away does my dog need to be before we want to open the door? So let's just say this is far. This is at about like 50 centimeters. Let's just say we want the dog door to open when it gets really close. So you're going to maybe decide that you want it to come in when it gets to 10 centimeters away. So you're going to have to decide what that point is when you build your final code. So now that we've got our input device working, let's go ahead and let's get the output device ready. Here we go.